Good morning, students. Uh, Good morning, students. Today, we will like to discuss about the uh, bijectivity, bijective, and inverse function. In fact, this type of question in ISC and CBSC is frequently coming, and it's a preparation for 4-mark questions. Now show that, just you see this question, show that the function f of x is equal to x minus 1 divided by x minus 2 is bijective. Two sets are given to you, that is this function is valid for a certain values of x. Here you see, if x is equal to 2, then this function is not valid, it is undefined. That's why the set A is given all real values minus 2, other than 1, this function is valid, or minus 2. And the set B is basically representing y. Corresponding to this is basically the range, that is r real number other than 1, that we will find out after finishing the subjectivity of the functions, once we finish that. So for bijectivity of the function, already I told that what we will basically want to do, we have to prove whether this function is injective, what I already explained in my previous video, and surjective. If this function I can prove that as well as supports injectivity as well as subjectivity, then this function will be called a bijection or bijective function. Let's try to find out how we can solve it. See, for injectivity test, you write in this way: injection. For injection, you know that if f of x, the definition of injection, f of x is equal to f of y, this implies and does implies x is equal to y. This is we would like to prove. Now, what is the f of x? Your f of x is x minus 1 divided by x minus 2, where its domain is given r minus 2 for set A. So for this f of y, if I will be what? Suppose this is y is equal to, so y minus 1 divided by y minus 2. I will just substitute it like the previous sums. So if f of x is equal to f of y, we can write what? X minus 1 divided by x minus 2 is equal to y minus 1 divided by y minus 2. Now cross multiply. If you cross multiply, you will get what? X minus 1 into y minus 2 is equal to y minus 1 into x minus 2. So the result of the product will be xy minus 2x minus y plus 2 is equal to xy minus 2y minus x plus 2. So xy gets cancelled, and this minus 2x, this 2 also cancelled, and minus 2x, if you transpose over here, this will be minus 2x plus x, and here minus 2y plus y. So finally we got minus x is equal to minus y, and that is x is equal to, this implies, here you write that x is equal to y. So this is the procedure that how we can prove that this is injective. That is, for each x there should be at least only one image. For each domain, for each values of x there should be only one domain, and for considering this condition. So this is how we can prove the injectivity. Now let us see how we can prove the subjectivity for these given conditions. For subjectivity, children, as I told you that we have to express x in terms of y. That is, we have to express x as a subject and y as an object. Let us see that how we can do that. So for surjectivity, for surjection, let y is equal to, here you start in this way, y is equal to. So now you cross multiply again, so you can get xy minus 2y is equal to x minus y. So to express x in terms of y, we will bring all the x values over here and all the y value to the right hand side. So xy minus x is equal to 2y minus 1. If I common x into y minus 1 is equal to 2y minus 1, and therefore x is equal to 2y minus 1 divided by y minus 1. Now just check these values. This is actually the exactly supporting these conditions, because here if you put y is equal to 1, then this x will be undefined. So basically this is the expression that we want, and hence x is expressed in terms of y. This actually imply that for all real values of y other than minus 1, so write over here, for all real values of y other than 1, okay, other than 1, there exists a corresponding real values of x other than, following that condition 2. Children, you must write this statement. If you don't write this statement, you will lose 1 mark. So for expression of this, you can get 1 mark, M1, and for writing this, you can get 1 independent marks, B1. So this is important, and here also for cross multiplying, here you can get 1 marks over here. Here you can get 1 marks, and for proving x is equal to y, you will get 1 B1. So this is how we can get the 4 marks, and you should know also the marking scheme of CBSE and ISC, and you have to follow accordingly. This is how we have proved that yes, this function is also surjective. To search for surjective, I repeat again, you have to say y is equal to this, you cross multiply, and then you have to express x in terms of y. You have to bring it. This is x as a subject, and this is y as an object. And then you have to write this statement for all y other than 1. If you put over here y is equal to 1, this will be undefined. So if you, other than, for any real values of y other than 1, this x is to be defined even except 2. So this is the conditions given, and hence we have proved that this function is also surjection. And as this function is both supporting injection and surjection, so here you write as if satisfy both surjection, both injection as well as surjection, the function is bijective. Now, so once you prove it is bijective, children, so next is the concept of inverse. Remember, if a function is bijective, only that function will be invertible. If a function is not bijective, then we cannot say the function is invertible. Means suppose the function is not 1, 1. So if the function is not 1, 1, it should be many 1. So a many 1 function cannot be bijective. Similarly, a function may be 1, 1, but it is not surjection, that is onto. Suppose it is into functions. So if the function is 1, 1 but into, then also that function cannot be bijective. And as the function is not bijective, we cannot say the function is invertible. But here we have proved for this given condition that the function is 1, 1 as well as surjection or onto. Therefore, you can say the function is bijective, and as it is bijective, it must be invertible. So you can write this, therefore, the function is invertible. Once we have proved the function is invertible, so next job is how to get the inverse function. It's very easy, children. What you can do, it is the expression of x, you just substitute instead of y, x, and here you write f inverse like this. That is, for inverse function, you can apply, just you write here f inverse of x, and here just substitute x over here. So write over here f inverse x, 2x minus 1 divided by x minus 1, and that is the expression of inverse function. And if it is a 6-mark question, naturally for writing this you can get 1 marks V1, okay, and for writing this invertibility you can get another one V1. So in this way, children, you can get the inverse functions. So this is all how to solve this type of rational expression. That is rational. It's clearly a rational expression. It's a division of two polynomial to linear expressions, and that is a polynomial. This is how we can tackle or how you can prove a rational expression can be bijective. Thank you very much.